Captions in English, please. So this is the 6th video on chapter 3, and it's focusing on separating a mixture. But before we look at that, let's finish about physical and chemical changes. And this slide shows you examples of a physical change and a chemical change using the same substance to start with. And that's liquid butane, which is found in lighters, right? When you're using a lighter, you're burning butane to create the flame. And so the liquid butane is liquid inside the lighter, but it's very volatile. And so if you look at picture on the left, if you are opening by pushing down on the green lever here, if you open the valve, then the butane can escape as a gas because it's very volatile and it will escape as a gas. So you see those gaseous butane molecules escaping. And that represents a physical change, right? We have the same substance at the beginning and after. Next, on the right, we have the same lighter, liquid butane. And this time, if you strike the stone and create a spark, you can ignite the butane and create a flame. The flame is due to the fact that butane is burned. So it's a combustion reaction where butane is changed into carbon dioxide and water molecules. So now it's not butane anymore after the change. It's a chemical change because butane becomes two different substances using oxygen from the air. So combustion reactions or burning are chemical changes. So let's go through this concept check to verify that you can apply those different terms, physical change and chemical changes. So again, pause the video to work this on your own before you watch the answer. So copper metal forming a blue solution when dropped into nitric acid. Is this representing a chemical change or a physical change? So here, copper metal, we know it's a reddish, shiny metal. If you put it into a nitric acid, you see that the solution becomes blue. It was not blue before. And you will probably see the metal, looking black and corroded. And so that typically represents a chemical change. The blue in the solution is actually due to the copper 2+ ions. That's an ion that gives a blue color to solutions. So that means the copper, first as a solid metal, became an ion in solution. So that really represents a chemical change. When a train runs over a penny on a train track and flattens it, is this a physical or chemical change? The penny is made of copper again, but it becomes all flattened. But it's still copper, it's still reddish, shiny, and a solid piece of metal. So that's a physical change. You only change the shape of it because copper, as all metals, is malleable, so you can change its shape. Third example, when a match ignites a firework. Is this a chemical change or physical change? When you ignite a firework, whenever there is a combustion, which means burning, which means fire, flames, this implies a chemical change. Chemical change because the powders that are making up the firework will be burned and will produce those sparks and beautiful firework. And what will be left will be, ashes and dust, and it's different substance afterwards. So this represents a chemical change. So separating a mixture. We know that in around us, we see some pure substances, But most of the time, what we see around us are mixtures. There's much more mixtures than pure substances. But the question is, can we separate the mixture and obtain the pure substances back? And yes, we can. And we can do it based on the different physical properties of the component. So if your substances have different physical properties, this will allow you to separate them. If you were separating them based on chemical properties, this would not be, you would not separate them into substances that you had at the start. So it has to be based on physical properties. For example, the state of matter. So if you have a solid mixed with a liquid, a gas mixed with a liquid, or a solid and a gas together, you can easily separate them using the fact that they are in different states. And what comes to mind is the filtration. Filtration is used systematically to separate a liquid from a solid. If you have a solid in suspension in a liquid, you can pour that into a funnel that contains a filter paper. The solid will be retained in the filter paper, and the liquid will go down the funnel into the recipient, that the container that is below. So this way you can separate a liquid from a solid or a solid from a liquid. If you are using the physical property of boiling point, you can separate substances by using the technique of distillation. So distillation is a technique that allows the separation of mixtures based on boiling point. So you use the fact that your substances are having different boiling point. So if we look at the left schematic here, you have the round flask that contains the mixture, and here it's salt water. So we want to separate the salt from the water. So for this, you will warm the salt water with a Bunsen burner. And we know that salt will not evaporate before water. We know that water will evaporate at 100 degrees Celsius. So when you reach the boiling point of water, water will evaporate into steam. And then the steam moves up because it's less dense. And then it's allowed to go through a condenser. That's this double wall tube that is cooled down. So the double wall allows water, cold water, to run into the two walls. And this makes it a cooler area. And the steam, when it goes there, it will be cooled down, and so it will condense. So it will be back into droplets, and those droplets of water, of liquid water, will flow down due to gravity into the Erlenmeyer flask, which is the triangular flask where you recover pure water. And you continue until you have evaporated all the water. And according to the schematic on the right, at the end, you have pure water in the triangular flask. And in the round flask, you have only salt. The salt now is crystallized, and it was dissolved at first, but here, by removing all the water, you recrystallized it as a solid. So distillation is a technique that allows you to separate a solid from a liquid, but also a liquid from another liquid, or two gases. You can separate gases also this way. So it's used, for example, in making of alcohols. So if you have a mixture with water and different alcohols, you can use the distillation to separate the different alcohols, because they will most likely have a different boiling point. So now that you have a pure substance, the question is, can you separate it into, can you separate the compound into an element? We know that elements are substances that cannot be broken down into simpler substances, right? That's the basic of matter. It's the basis of matter, and we cannot break it down. And it's going to be pieces of atoms instead of, atoms. So we cannot go more down than at the size of an element. But can we separate a compound and retrieve the elements that are composing that compound? Well, yes, we can. And for example, we can do that with water. So elements can be separated from compounds based on different chemical properties of the component. So this time you will need to use the chemical properties, because a compound is already a pure substance. So physical properties will not be helpful anymore. This time you need to reach the level of chemical change to destroy the compound into its elements. And this schematic here is showing an example of electrolysis. Electrolysis, so there is the base word electro, which means you're using electricity, and lysis means to cut into pieces. And so electrolysis uses electrical current to separate a compound into its elements, to break down molecules. And in this example, we have the electrolysis of water. So in the glass, E-shaped container here, we have water. And we have a source of direct current, or a battery. And then the electrodes are, one of the electrodes is put in one side of the container that contains water, and the other on the other side, so that we can recover the two elements of oxygen and hydrogen separately. Because when you do run an electrical current through water, it breaks the water molecule into oxygen gas and hydrogen gas. But the oxygen gas will form at the one of the electrode, and at the other electrode it will be the hydrogen gas. And so this way, by separating the electrodes, you can separate the two gases and produce oxygen and hydrogen. But it's a breakdown where you need to bring energy and create a chemical change here.